Imagine this: the SpaceX spaceship, a colossal powerhouse carrying the weight of a new era in space travel, is preparing for landing after a successful mission. Everything is going smoothly until an unexpected issue arises. Russia steps in. The ship begins to shake, warning lights flash errors. What could have gone wrong? What if it's not just a technical glitch, but something far more intriguing? In the heat of the space race, Russia intervenes in SpaceX's mission, attempting to sabotage the landing of one of the most powerful spacecraft in history. A nail-biting moment that could cost billions of dollars in future space ambitions. This story, which nearly derailed the highly anticipated Starship landing, shows just how thin the line is between success and catastrophe in space. The SpaceX Starship project isn't just another step in the evolution of space travel. It's a next-gen spacecraft capable of delivering up to 100 tons of cargo to orbit and beyond. Designed by Elon Musk for future Mars missions, Starship's innovative propulsive landing challenges traditional spacecraft recovery methods. It's no surprise that Russia's begun exploring similar technologies, trying to catch up with SpaceX in this race for space dominance. However, other space systems like the Russian Soyuz or the Chinese Long March lack the versatility and innovation of Starship. Their landing methods are more limited and depend on external factors such as weather conditions. In comparison, Starship can achieve a pinpoint landing on any surface from the Moon to Mars.
And as we move, to the Moon and Mars and beyond, we're writing the narrative of human spaceflight right now.
As they prepared for another mission, the SpaceX team faced immense pressure. Every detail was meticulously checked, from the state of the fuel systems to the performance of the Raptor engines, each capable of generating over 2 million newtons of thrust. The Raptor engines run on a methane-oxygen fuel mix, making them more powerful and eco-friendly than those of competitors. However, the development of Starship wasn't without challenges. Despite being the most powerful engines on the market, the Raptors initially faced thrust stability issues during flight. SpaceX resolved this by upgrading the fuel system, enabling more precise fuel delivery under high loads. Additionally, the SpaceX team encountered challenges with the spacecraft's aerodynamic stability during re-entry from orbit. Through numerous experimental flights and simulations, they optimized the design of the aerodynamic control surfaces. One of Starship's greatest technological achievements is its ability to perform a propulsive landing. This means that the spacecraft doesn't really rely on parachutes or traditional landing methods, but instead uses its engines to slow down, controlling both speed and position. Notably, at the time of Starship's creation, no other spacecraft could execute this maneuver with such precision.
You can add up all the rockets launched by other rocket companies in the United States, and it doesn't come close to what SpaceX is doing.
Its closest competitors, such as Russian spacecraft or European Ariane rockets, still rely on parachute systems, which are less precise and risky during strong winds or other adverse conditions. This technology even inspired Russian engineers to develop similar systems, but no one expected that during this landing, issues could arise due to external interference.
Its initial target mission is to bring astronauts in orbit around the Moon in order to lay the groundwork for a new space station that will...
Despite all expectations, the event drew massive interest. Musk's supporters saw it as another step into the future, while critics were ready to find weaknesses in the technology, as the development of Starship came with a series of challenges. The main issue was the thermal protection system. A spacecraft traveling at over 15,500 miles per hour faces intense friction upon re-entry into the atmosphere, causing its surface to heat up to temperatures exceeding 2,700 degrees Fahrenheit. To address this, a special heat shield tile was developed, capable of withstanding such extreme temperatures without disintegrating. However, integrating it into the spacecraft structure required numerous tests from SpaceX. So what went wrong during the last landing attempt? As it turned out, during the final landing phase, when Starship was approaching Earth, communication with the spacecraft was suddenly cut off. A few minutes of uncertainty turned into a full-blown crisis. According to insider reports, Russian electronic warfare systems may have interfered with the spacecraft's communications, disrupting its real-time control. This isn't the only theory. Some experts suspect that Russia might have employed more aggressive tactics, such as direct interference with the navigation systems through satellite jamming. As a result, Starship was unable to perform timely braking, causing the landing attempt to fail. The public's reaction was mixed. Some believed it was just an unfortunate accident, while others started buying into conspiracy theories suggesting that Russia is deliberately trying to sabotage SpaceX projects to prevent the U.S. from gaining a strategic advantage in space. After the incident, the issue of space mission security took center stage. Media outlets actively discussed the possible causes of the failure and the importance of protecting spacecraft from potential attacks or disruptions. Experts emphasized that even the most advanced systems could be vulnerable to external threats, which introduces a new level of challenges for future missions. In his response to the incident, Musk stated that SpaceX is already working on enhancing its protective systems. Among the proposed solutions are strengthening communication encryption and implementing more resilient navigation systems that won't be susceptible to external interference. So this situation once again highlighted how complex modern space missions are and how many factors can impact their success or failure. However, SpaceX has always been quick to adapt and learn from its mistakes, and this case is no exception.
Launching and landing of rockets is not something that they invented, but something that they've perfected and something that they were able to bring to market.
This highlights the importance of technological innovations like propulsive landing, which allows for quick responses to unexpected situations. After analyzing the incident, SpaceX engineers concluded that similar threats could be accounted for in future missions by including additional security systems and backup communication channels. Elon Musk confirmed that this event would serve as an extra incentive to improve technologies that ensure safety during space missions. What do you think? Could it be that hypersonic planes will become a critical element of national security in the coming decades? The answer may be closer than you think. And the SR-91 Aurora aircraft, rumored to have undergone upgrades by Elon Musk, might hold the key to this future.
It will operate in tomorrow's high-end threat environment, and it will enable America to outmaneuver, to outpace, and to outmatch our adversaries. It will deter aggression.
The SR-91 Aurora isn't just another aircraft, it's a revolutionary hypersonic vehicle that promises to transform the very nature of air travel and military operations. Although its existence has long been shrouded in secrecy, rumors about its capabilities have circulated since the 1980s. Imagine this aircraft reaching speeds exceeding Mach 5, over 3,700 miles per hour. Such a pace would allow the SR-91 to cross the Atlantic Ocean in under an hour. But now, with Elon Musk reportedly involved in the modernization of this aircraft, the scale of its development could reach new heights. Musk, known for his ambitious projects with SpaceX and Tesla, views the SR-91 as a platform to test cutting-edge hypersonic technologies. His vision goes beyond just improving speed and efficiency. He aims to bring hypersonic travel to the commercial market. In this video, we'll take a detailed look at how the SR-91 Aurora could become the symbol of a new era in aviation and the key role Elon Musk plays in its enhancement.
What it might look like, it's to describe a vision more than anything else. It's to put something tangible in people's minds as to what.
Hypersonic technologies face several serious challenges, with the primary one being the impact of extreme speeds on the aircraft. For example, when traveling at speeds exceeding Mach 5, approximately 3,830 miles per hour, the surface temperature of the vehicle can reach 980 degrees Celsius or higher. Standard materials used in modern military aircraft cannot withstand such heat, which creates the need for new, heat-resistant composites that can endure these extreme conditions without losing strength. Another significant challenge is the power systems. Traditional turbojet engines cannot sustain stable operation at these speeds due to excessive temperatures and pressure inside the engine. For instance, the F-119 turbojet engine used in the F-22 Raptor can achieve speeds of around Mach 2.25. But its design wouldn't withstand the demands of hypersonic speeds. For projects like the SR-91, hypersonic scramjet engines are being considered. These engines are capable of functioning at speeds beyond Mach 5, making them ideal for such high-speed applications.
Biggest thing I've seen as far as aviation.
Another challenge is navigation. Hypersonic flights pose massive difficulties when it comes to precise control. Traditional navigation systems lack the required accuracy at such high speeds, which significantly increases errors in trajectory calculations and delays in control system responses. As the world faces new challenges in national security, reaction speed and mobility have become critical factors. This is why developing hypersonic aircraft is of strategic importance for defense. The SR-91 Aurora, with its potential for lightning-fast delivery of information, munitions, or even conducting reconnaissance missions, could become a key tool in maintaining the U.S. technological edge amidst growing international competition. The story of the SR-91 Aurora begins in the post-Cold War era, when the United States sought new ways to surpass potential rivals in the airspace. According to unconfirmed reports, the first tests of this aircraft took place in the 1990s, but its exact capabilities remain classified to this day. However, it's believed that the Aurora was intended to replace the legendary SR-71 Blackbird, a spy plane capable of reaching speeds of Mach 3.2, about 2,170 miles per hour. The SR-91 Aurora is not just an aviation legend, but one of the most mysterious projects of the U.S. Air Force. Its design reflects cutting-edge advancements in aerospace engineering, though its precise technical specifications remain mostly classified. Estimates suggest that the aircraft is about 130 feet long with a wingspan of 65 feet. It features a wedge-shaped design that minimizes aerodynamic drag at hypersonic speeds exceeding Mach 5, more than 3,720 miles per hour. The plane is also believed to be capable of reaching altitudes above 98,400 feet, making it nearly invisible to enemy radar systems.
The advantages to the wing design, to the flying wing design over a traditional aircraft is the replacement of that fuselage with more wing. So that creates a bigger surface area of wing, which translates into more lift.
Particular attention is drawn to the hypersonic engine of the SR-91 Aurora. It's believed that the Aurora is equipped with a scramjet engine capable of operating at speeds exceeding Mach 5, where traditional turbojet engines fail due to excessive heating. For comparison, a conventional jet engine reaches temperatures of around 1,110 degrees Fahrenheit, while the Aurora's body can heat up to 3,630 degrees Fahrenheit during flight due to air friction. To withstand such extreme conditions, the aircraft uses special materials based on titanium or carbon, which can handle these temperatures. These materials not only enable the plane to endure the unusual conditions of hypersonic flight, but also improve its maneuverability. Furthermore, Elon Musk plans to use technologies from SpaceX to develop next-generation engines that'll run on liquid methane and oxygen. This will significantly reduce the weight of the fuel system and increase the aircraft's range. Another important aspect is autonomy. Elon Musk is a strong advocate of artificial intelligence, and he plans to integrate an automated flight control system into the SR-91. This will not only make flights safer, but also enable the SR-91 to carry out missions without a pilot. Such a control system will allow the aircraft to avoid enemy detection systems and conduct reconnaissance missions at hypersonic speeds.
The wire takes inputs from the pilot and other aircraft sensors, feeds them into a series of computers, which then produce an output to a hydraulic actuator, which moves the flight controls for it.
Conspiracy theories have inevitably surrounded the SR-91 Aurora. One of the most well-known stories involves its alleged testing at Area 51, the secret U.S. military base. Witnesses have repeatedly reported seeing strange phenomena in the sky, which they mistook for UFOs. Some experts believe these sightings could actually be linked to the testing of the Aurora. There are even suggestions that the technologies used to build this aircraft were borrowed from extraterrestrial crafts, possibly recovered in Roswell in 1947. While this remains purely speculative, for many conspiracy enthusiasts, it adds an extra layer of mystery to the Aurora project. Returning to the modernization efforts, one of Musk's most impressive proposals is the use of a new engine cooling system. Traditionally, at hypersonic speeds, engine temperatures can reach thousands of degrees, posing a serious threat to their reliability. Musk suggests using liquid nitrogen for rapid cooling during flight, which would extend the engine's lifespan and prevent overheating. Additionally, this technology would allow the aircraft to stay airborne for longer periods, significantly boosting its combat effectiveness. Another revolutionary aspect is the improvement of aerodynamics. By utilizing special composite materials, Musk plans to make the SR-91's body smoother, reducing air resistance. As a result, the aircraft could reach speeds of up to Mach 8, around 6,100 miles per hour. This would make the SR-91 the fastest aircraft in the world, capable of reaching any point on the planet in just a few hours. The SR-91 Aurora is more than just another military aircraft. It's a platform that could revolutionize our understanding of air transport and combat operations. With Elon Musk's involvement in its modernization, this aircraft is set to become a symbol of a new era in aviation. Innovative materials, cutting-edge engines, and autonomous control systems will make it not only fast, but also highly efficient and safe in combat situations.